The paper of the day is the Volcano Optimizer Generator, Extensibility and Efficient Search. Emerging database application domains demand not only new functionality but also high performance. To satisfy these two requirements, the Volcano project provides efficient, extensible tools for query and request processing, particularly for object-oriented and scientific database systems. One of these tools is the new optimizer generator. Data model, logical algebra, physical algebra, and optimization rules are translated by the optimizer generator into optimizer source code. Compared with their earlier Exodus optimizer generator prototype, the search engine is more extensible and powerful. It provides effective support for non-trivial cost models and for physical properties such as sort order. At the same time, it is much more efficient as it combines dynamic programming, which until now had been used only for relational select, project, join optimization, with goal-directed search and branch-bound pruning. Compared with other rule-based optimization systems, it provides complete data model independence and more natural extensibility. Let's look at some of the design principles. There are 5 fundamental design decisions embodied in the system, which contribute to the extensibility and search efficiency of optimizers designed and implemented with Volcano Optimizer Generator. First, while query processing in relational system has always been based on relational algebra, it is becoming increasingly clear that query processing in extensible and object-oriented systems will also be based on algebraic techniques, that is by defining algebra operators, algebraic equivalence laws, and suitable implementation algorithms. Second, rules have been identified as a general concept to specify knowledge about patterns in a concise and modular fashion. And knowledge of algebraic laws as required for equivalence transformation in query optimization can easily be expressed using patterns and rules. Thus, most extensible query optimization systems use rules, including the Volcano Optimizer Generator. Furthermore, the focus on independent rules ensures modularity. Third, the choices that the query optimizer can make to map a query into an optimal equivalent query evaluation plan are represented as algebraic equivalences in the Volcano Optimizer Generator's input. Other systems use multiple intermediate levels while transforming a query into a plan. The fourth fundamental design decision concerns rule interpretation versus compilation. In general, interpretation can be made more flexible. In particular, the rule set can be augmented at runtime, while compiled rule sets typically execute faster. Since query optimization is very CPU intensive, they decided on rule compilation similar to the Exodus optimizer generator. Finally, the search engine used by optimizers generated with the Volcano optimizer generator is based on dynamic programming. Now let's look at the contributions. Authors' earlier experiences with the Exodus optimizer generator had been inconclusive. While it had proven the feasibility and validity of the optimizer generator paradigm, it was difficult to construct efficient production quality optimizers. They designed a new optimizer generator requiring several important improvements over the Exodus prototype. First, this new optimizer generator had to be usable both in the Volcano project with the existing query execution software as well as in other projects as a standalone tool. Second, the new system had to be more efficient both in optimization time and in memory consumption for the search. Third, it had to provide effective, efficient, and extensible support for physical properties such as sort order and compression status. Fourth, it had to permit use of heuristics and data model semantics to guide the search and to prune futile parts of the search space. Finally, it had to support flexible cost models that permit generating dynamic plans for incompletely specified queries. In this paper, they describe the Volcano Optimizer Generator, which will soon fulfill all the requirements above. Now, let's talk PS score for this paper. Overall, this paper is a nice read, so it gets 8 out of 10 on readability. With 10 pages long, it scores 8 out of 10 on length. It's an analysis paper focused on Volcano Query Optimizer Generator with decent description, so that makes it 8 out of 10. Its industrial and learning material is good, so it gets 8 out of 10 on each. Overall PS score is 8 out of 10.